Welcome to this webinar, and it is a great pleasure and honour to be presenting. I am Stephen Roberts, one of the co-founders of Mind Foundry and Professor of Machine Learning at the University of Oxford. So let me start out by asking the all-important question about what AI actually is. I think this is a question with an answer that could take many hours. Don't worry, I'm going to try and do this just in a few minutes. And in my mind, artificial intelligence has its beginnings many centuries ago. Some of the first people to talk about AI in a modern guise were in the 19th century, including luminaries such as Ada Lovelace and Charles Babbage. Lovelace and Babbage in the 19th century had aspiration to understand the mathematical equations that govern consciousness, the understanding of how we as human beings achieve conscious action and agency. And their work directly led on through to the 20th century predecessors of much that we do today, such as the legends such as people like Alan Turing. So although AI itself and the study of the mathematics and computation of conscious decision making and action have got a very long history, I think it's right to say that it's only in the past decades that we have become very aware of the possibilities that such mathematics and computer science could do for the world. I would like to comment that we in Mind Foundry, and certainly as an academic, we know very clearly what AI is not. And I think it's worth saying AI is not a cure-all, a magic formula which solves every problem that we see out there in the world today. We can't just throw AI at our problems and hope that it will immediately solve absolutely everything. It is not snake oil. It isn't a mythical beast like a unicorn. And it is not Professor Snape, a magical potion master who can create solutions for absolutely every problem. And in my mind, and certainly in the minds of all of us in Mind Foundry, it is math, not magic. It is based on principles of science, not superstition. And it is very much in that scientific foundation that I believe real achievements in AI have been made. In order to move AI and understand its concepts from a mathematical and computational perspective, essentially we just need a computer, and a computer is a logic engine. Here, rather elegantly from the 19th century, we have one of the world's first real computers. This is Babbage's analytic engine, and that comes from the early part of the 19th century. Then it is a mechanical computation engine, but it has all the components of a modern digital computer, including the ways in which it is a general purpose computational engine that can be programmed. So we need somebody who is going to program things. And I'd like to make the distinction very clearly between algorithms which are classical algorithms, where what we do is we program in the rules of a solution themselves. And I think it's so important to understand that classical algorithms write cleverly the rules that define a solution. What modern AI does, or indeed all AI, is to use an algorithm which, rather than writing an algorithm to create the rules, writes an algorithm that allows the computer itself to learn rules from data. And so what the algorithm is really doing is defining a strategy, defining a set of rules, given examples from the real world and examples of what good looks like. So we give data and we say what the target answer should be. And this is AI, whether on a small scale, everything from really simple algorithms the simplest, such as the genesis of AI in the 1950s and 60s, right the way through to impressive ways in which AI plays games and beats human beings, and the way in which things like ChatGPT work. It is all about providing an algorithm with the ability to learn from data, from raw data, to see the data and know what the answer should be, conditioned on what it sees out there in the real world. We can apply that to any phenomenon where we have examples and we have some kind of target, and the AI system will learn an algorithm from examples and targets, which can then go on to generalize and transfer those rules to new things that it sees out there in the real world. And again, that could be just fitting functions, or it could be about building an incredibly sophisticated ChatGPT-like system that solves very general problems or very bespoke problems. And we're seeing very narrow AI using ChatGPT for solving medical diagnosis problems, chat bots in very specific domains like law, finance, and science, or beyond. So this is a very, very transferable phenomenon. And this approach can work whether we're trying to build drop-down menus and understand AI phenomena. Here is just a case study of classifying fruit, right the way through to more complex things such as building spam or fraud detection in an email client and beyond. So, based on this very, very simple premise, which really does cover absolutely everything, and it's about providing AI with the ability to create algorithms that learn from example, the history of AI really goes back so far. And I'm not going to talk about hundreds of years of phenomena associated with AI, but actually think a little bit about the landmarks which really earmark it. It's really worth seeing AI, though, as part of a revolution in the automation of human reasoning. And I think hand in hand with the philosophy of automation and our role as human beings alongside automation, that goes to the philosophy of people like philosophers like Keynes and others, to understand how we can work with automation to produce the best of both of us. This goes right the way back to the machine age and the industrial revolution of the 18th century through to the 19th century. Computer visionaries like Lovelace and Babbage and others, along with people who worked on economic theory to understand how these automation were going to affect society and economics. People like Keynes and others, to understand how automation is going to displace workers. And I think that's as important today as it was in the 19th century. Then we have the classic era of symbolic solutions and the digital repetition revolution that took place from the 50s onwards. That's something which really spearheaded the modern AI revolution. And then from the 70s onwards, goodness, the exponential rise in automation and in clever, intelligent algorithms. And I've put together a very, very simple timeline of key events within the AI history timeline. And I think that, to my mind, modern AI starts with people like Alan Turing publishing Turing tests. What does it mean to be human and intelligent? What does it mean for an intelligent algorithm to mimic human behavior? And again, I think that's an important question in a modern era, even more so with the publishing and the revolution that is now created around things like ChatGPT. The phrase artificial intelligence was actually coined in the mid-1950s. It went hand in hand with pioneers like Rosenblatt, who created the single layer perceptron, which was one of the first algorithms that ran on an all-purpose digital computer, which would try and learn from example. So it had a training set and it would learn from those examples. This led on to the 1960s to the first precursors of natural language processing, and then was a large language model. We would think of it as a very small language model that was language models like ELIZA. We begin to get the very first neural network era in the 1980s, and I'm old enough to have been working in that area, culminating in things like impressive phenomena such as Deep Blue, the IBM all-purpose digital algorithm, which amazingly beat Garry Kasparov, the then grandmaster champion in chess. You begin to get then in the late 1980s impressive behavior of things like convolutional neural networks pioneered by Jan LeCun and others, and the way in which they could achieve human-like performance in image processing. We beget deep nets, which are ever more capable at vision tasks. And then we have pioneering landmarks such as DeepMind's Go algorithms, which very famously beat the then champion at Go, Lee Sedol. And this led directly on to incredibly impressive landmark advances from not only the academic world, but also importantly, the commercial world, who were able to scale these amazing phenomena and these amazing algorithms. AlphaGo led to AlphaGo 2 and led on to things like AlphaFold in the 1980s and 2020s. And then we begin to see a few years ago OpenAI coming into the commercial mix alongside Amazon, Facebook, and Google and DeepMind, and releasing some of the large natural language processing algorithms based on foundational models such as GPT-1, 2, and 3, and of course more recently GPT-4, which has caused an enormous excitement in the world and the media because of what it can do and its human-like capability. Foundational models, I think, are the buzz of today. They can do things which are apparently human-like in their complexity. This brings me back as a really nice segue to say what these are really doing is kind of learning the rules of what good looks like to a human audience. And that is right the way back, bringing our way back to Turing and the 1950s to say, what does an algorithm look like which can mimic a human being in a task? That does not mean it is human, and it doesn't mean it's conscious in any way whatsoever, but it does mean that we've found a solution, a recipe for creating algorithms that learn solutions which can fool human beings and produce answers that are so human-like that we ascribe human-like agency to that algorithm. And I'd argue generative and foundational models like GPT-4 are able to do exactly that. The evolution of AI technology is something that is phenomenally complex, and we see things like uncertainty-aware AI, meta-learning, wisdom of crowds, large language models, generative models, human-centric AI, human in the loop, as well as really interesting perfections of the future, such as the role that quantum computation is going to play in the future. All of these things, we in Mind Foundry have the privilege to be part of this journey, this very long journey that's been hundreds of years in the making, and to play our small part. And through our liaison with academic partners, try and make that small part have a really positive impact for good in the world of technology.